Hey guys, welcome back to my page. I hope you guys are doing fine. So let's just remind each other of what we did in the previous video, then we can move to the next step or next topic. So we talked about algorithms in the previous video, looked at flowcharts, talked about the operators used in algorithms, also talked about pseudocode, then we defined what computer programming was. So today we're just going to take a look at a few examples of algorithms, see how we can solve problems using algorithms. And the solutions to each example is divided into three parts. We have the pseudocode, we have the algorithm part, and we have the flowchart. So let's take a look at the first example. The first example says write an algorithm to determine a student's final score and indicate whether it's passing or failing. And the final score is calculated as average of the 3 marks. So in this case, we have three scores in short, and we're going to start with pseudocode. So as we already said in the previous video that we use pseudocode just for human understanding. So this is a code where we have to write in words, not like the normal computer programming. We have to write in words for people to understand easily what we're talking about. So according to this example, let's write the pseudocode. Since we have three scores, so we're going to say input a set of 3 marks or 3 scores. Calculate their average by summing and dividing by 3, because we've been given 3 scores, so we need to find the sum of these scores, then divide them by 3 to find the average, because the average is going to help us in determining who's done well and who's done bad in terms of the academics. Then we're going to we need to give a condition, like we need to define we need to declare our passing mark. So in this case I just gave an example of 50, because normally if someone gets below 50 then they failed. If someone gets above 50 then it's a pass. So we're going to say if the average is below 50, print fail. That's our first condition. Else print pass. So our first condition is one, a student gets below 50%, meaning they failed. But if they've gotten above 50%, meaning they've passed. So let's write this pseudocode as an algorithm. And in algorithm, you need to, like, whatever step you take, you need to specify this is step 1, this is step 2, this is step 3. Because there are cases whereby you need, when you're trying to make a decision, you might be forced to go back to a certain step. Could be step 1, could be step 3, or anything. So we're going to say step 1, as we've already said, we have 3 scores. So we're going to say step 1 input M1, M2, M3. In this case, M represents mark. So we're going to say step 1 input M1, M2, and M3. Then step 2 is where we want to find the average of the scores to determine which student has passed or failed. So we're going to say step 2 score, like in this case we're trying to find the average. So we're going to say step 2 M1 plus M2 plus M3 divide by 3, which is going to give us the average. Then we give the condition, if score is less than 50, then print fail. Else print pass, then end the program. So let's take a look at the flowchart of this problem. Just a minute. So as we've seen already, this flowchart is just something summarizing the code we've written, like the algorithm we've written. So let's take a look at the second example, or the second problem. So the second problem says write an algorithm and draw a flowchart to convert the length in feet to centimeter. In this case, we're trying to convert something to something. Yeah, to something else. It could be distance, could be height, could be weight, could be anything. Like, we're just trying to, like in our case, we're trying to find, we're trying to convert feet into centimeters, not feet as in the feet, but feet, the length. Yeah, so let's take a look at the pseudocode of this problem. We're going to say, since our input is length in feet, because that's what we're trying to convert into something else. So our input is the length in feet. Then we have to calculate the length in centimeters, but by multiplying the length in feet with 30, sorry, because as we already know, 30 centimeters is equal to 1 feet. So for us to convert the feet into centimeters, we need to multiply it by the length in centimeters. Then we print the length in centimeters. That will be our answer. So let's take a look at the algorithm of this problem. Actually, this problem is not that difficult. I think it's one of the simplest. This problem also just has 3 steps in, like, the algorithm has 3 steps. We just say input length in feet. Then you multiply the length in feet by 30 for us to get the length in centimeters. So then you print the length in centimeters, then you end the problem. So let's take a look at the flowchart of this problem. As we've already seen, it's just something so simple. Our main process in this case is just multiplying the length in feet by 30, because 30 centimeters is equal to 1 feet. For now, let's take a look at the third example, which says write an algorithm and draw a flowchart that will read the 2 sides of a rectangle and calculate its area. So in this case, we're given a rectangle, and we have unknown values for each side. So we need to read these values and calculate the area of the rectangle. So let's write the pseudocode of this problem. So we're going to say input the width, is it width or width and length, because those are inputs in rectangles. Then we're going to calculate the area, which is A, by multiplying it with L. We're going to calculate the area, which is A, by multiplying L with W. In this case, we multiply the length with the width. Then you print A, which is area. Let's take a look at the algorithm of this problem. So we know input is W and L. Then first, to find the area, we multiply L by W, then you print A, then you end the problem, sorry. Then let's take a look at the flowchart of this problem. This is also very simple. It's not something that's complicated. Then here we come to my favorite of them. Our fourth example says write an algorithm and draw a flowchart that will calculate the roots of a quadratic equation, which is a x to the power 2 plus bx plus c, which is equals to 0. Given that d, which is the determinant, is equals to square root of b squared minus 4ac, and the roots are x1 and x2. And we know that x1 in this case is b plus d divided by 2a, and x2 is negative b minus d divided by 2a. So let's write the pseudocode of this problem. So in our case, our inputs are the coefficients, which is a, b, c, of the quadratic equation. But before we find the values of x1 and x2, we need to calculate for d, which is the determinant in this case. So let's input. So we're going to say input the coefficients, which is a, b, c, then of the quadratic equation. Then calculate d, which is the determinant. Then calculate x1, calculate x2. Then you print x1 and x2. Then you end the program. Let's take a look at the algorithm of this problem. It's also not that difficult, but it's something that's just somehow fun. So step 1, you input, calculate for x1, which is negative b plus d divided by 2 times a. Then you also calculate for x2, which is negative b minus d divided by 2a. Then you print x and x1 and x2. So let's just take a look at the flowchart, then we can end for today. Yeah, so thank you guys so much for listening. Have a blessed night.